Hello everyone. Today we are going to discuss about the cumulative distribution function for probability mass function and probability density function. We have already discussed about the probability mass function and probability density function in our last video. You can follow my last video to understand what is the probability mass function and what is the probability density function. So let's start this. So for continuous distribution, if you have a continuous distribution, then cumulative distribution function gives the area under the probability density function. As you know that this is your probability density function, like something. This is your f of x and this is your x and this is your PDF, probability density function. So whatever the area we have under this, area under the probability density function. So this, by using this CDF, we can get this particular area. And for discrete distribution, the CDF gives the cumulative probability for x value that you specify. This is your discrete, this is your discrete, and this is the probability 1, this is the probability 2. These are some probability corresponding to x. So what does it say? CDF gives the cumulative probabilities for x value. This is your 1, this is your 2, this is your 3, this is your 4, this is your like some probability like 0.2. So what does cumulative say? Cumulative says that it gives the cumulative probabilities for all x values. It means like a running sum up. Like if you talk about the CDF would be 0.2 plus again 0.2, again 0.2, again 0.2. We talk about till 3. What would be the CDF till 3? So CDF till 3 would be your 0.6. So this is the cumulative distribution for the discrete distribution. So let's understand in details one by one. So now we will discuss the cumulative distribution function for probability mass function. So keep in mind, probability mass function we use only for discrete random variable. So what is the CDF? CDF have some property like this. CDF tells that f of x is equal to probability of any random variable which has some outcomes like x. So we denote cumulative distribution CDF by using this particular f of x, capital F. This is also equal to, for you know that summation of f of x when this x is equal to minus infinity to x. So let's understand by one example what this particular definition says. That if you know, in our last video we had used dice example. You can follow my last video to understand what is the probability mass function. After that you can come back to this video, you will get some better picture. This is your f of x, this is your probability mass function, and this is your x. If we throw the dice, you will get the 6 possible outcomes like this. You will get 1, you will get 2, you will get 3, 4, 5 and 6. So what value you will get? What is the probability you will get at 1? Like if we talk about what is the sample space, you will get 1, 2, 3, 4, 5 and 6. So what are the first probability? If we talk about the f of x1, the probability would be 6. So same way you can calculate all the probability of 6. So same way, what is the probability of when we have a output value of the random variable is 1, then the probability would be 1 by 6. Same way the probability is same for all the possible outcomes here. So these are the possible probability value we have corresponding to each possible random values. So this is your probability mass function. Now by using this we need to calculate the cumulative distribution function. Cumulative distribution says that summation of all the probabilities from minus infinity to x. It means this is your minus infinity to x. X means any value like till 4, till 3, till 2. So summation of all the probabilities, like if you want to calculate the probability of 4, then the cumulative distribution till 4 would be summation of all the probabilities. I want to clear one more thing. In like videos or in blogs, you will get somewhere like f of x. Some use like only fx. Please don't be confused by using this particular way of representation, because x doesn't denote anything. It says that if we use fxx, okay, it says that what type of the variable you are using. X tells about the variable type. It nothing tells us anything. You can use even f of x, only fx if you want, or if you want you can also use the f of x. So both are the same. So let's use this particular probability function. So let's fx, if have some infinity to like 0, we are not taking the infinity, so let's just take a 0 value. So what is the probability of x? Because there is no anything, so we can say that probability x is less than, what is the value we are taking for x? X is equal to 0. So we can write this as a p x equal to 0. What is the probability at 0? We have that is equal to 0. So now we can calculate f of x as 1. So this will be equal to p when the x is less than or equal to 1. So this would be equal to probability of 1, then plus less than or 1. What would be the value before the less than 1? This would be your probability of 0. So we can say that this would be equal to 1 by 6. Now fx2, we can write that x is less than 2. So this would be equal to probability of 0 plus probability of 1 plus probability of at 2. So this would be equal to 0 plus 1 by 6 plus 1 by 6 equal to 2 by 6. So this way we can calculate for all ones, like fx6, this would be equal to like your p0 plus p1 plus p2 till p6. So this would be equal to your 0 plus 1 by 6 plus 1 by 6 plus 1 by 6. This would be equal to 6 by 6 equal to 1. Now plot the CDF. Let this is your 1, then 2, then 3, then 4, then 5, then 6. And then same here, we can use 1 by 6, 2 by 6, 3 by 6, 4 by 6, 5 by 6, then your 6 by 6. Now let me draw. This would be your x and this would be your capital F of x. So now let me draw the CDF. Let this is the 0. So before from infinity we talk about a 0 to, so till 1 we have the 0. This value would be your 0. So now start from F1. F1, what is the value we have F1 of CDF? CDF would be your 1 by 6 here. So again at 2, so till 2, 1 to 2, this would be your constant. Again we need to add this particular thing, like this particular addition here. So we will get this. Again till 3 here, this would be constant. Then again we will add. Then again this would be constant like 4. Then till 4 we have like 4 by 6. Then this again constant till 5. At 5 we will get 5 by 6. Then again it would be constant, and 6 we will get this value. Then again this would be constant value like this. So at here, what the value we are getting? 6 by 6 equal to 1. So this would be your 1 and this would be your this would be your 0. So this way you can draw the cumulative distribution function graph. By using this particular example, if anybody want to know what is the cumulative distribution probability at 5. So you can easily tell that 5 it would be 5 by 6. There are some properties we have corresponding to cumulative distribution function for PMF. So what is the property we have? First property we have, okay, this is the line we have, and this is your x value, this is your y value. So if y is greater than x, in that case your f or y will also be greater than your f of x. It means cumulative function of your y will be greater than cumulative function of your x value. It means it has increasing in nature. It means non-decreasing in nature. Second, if let x tends to infinity, like positive side, let this particular. So you can see here till 6 it is, after 6 whatever the value we will get, it will show the probability 1. So we can say that if x tends to infinity, then f of x cumulative distribution function will equal to 1. And third property we have, if x tends to minus infinity, like this direction, like, then you can see that this is the 0. So we can say that it tends to 0. So this is all about the cumulative distribution function for PMF. If you have any query or any question, please mention in the comment section. I will try to answer all of your query. I hope you will like my video. If you like, please share with your friends and colleagues. Thank you very much for watching my video. Have a nice day.